is to look at these fractions and can we find least common multiples or least common denominators for the fractions? So instead of multiplying and dividing fractions, of course, we can add and subtract as well. So that we're going to look today at finding the least common multiple or the least common denominator so that tomorrow we understand the process of finding them and we can apply that process to actually adding and subtracting the fractions together. So if I multiply and divide fractions, the other two operations would be adding and subtracting. So we will look at doing that tomorrow and on Friday, trying to add and subtract these rational expressions. So looking at your homework from yesterday, the worksheet contained a few problems of each type of example that we looked at. The first group of problems were just simplifying. You have one fraction, factor first, and then cross off any common factors between the numerator and the denominator. Number 5 contained a perfect cube. It's the only one that contained a perfect cube. And if you look at number 5, the numerator first, looking at that 2x cubed plus 54, there's a GCF. So we need to take out a GCF from the numerator. And that GCF we can pull out is a 2. When you pull out a 2, that leaves you with 27 inside. 27 is a perfect cube. Ella, in the denominator, what could we pull out there? Yeah. So then we have x squared, 3x, and plus 9. So before you go simplifying, look at the problem and see, yes, you factored, but did you factor completely? So we use the greatest common factor by pulling out what they have in common, but is it completely factored? And the quantity in the numerator is a perfect cube. That isn't completely factored if we have a way to break it down further by using those perfect cube formulas. So the A term is our x, and the B term is the cube root of 27 or 3. Thank you so much. Have a good one.
Yep.
So Jaden, how could I factor using the perfect cube formula, the x cubed plus 27?
I did x plus 3, and then I did in another parenthesis x squared minus 3x plus 9.
So A, same sign B. A squared, opposite sign, AB, always positive B squared. You can create a little jingle. That is now factored. The denominator is still that 4x and then x squared minus 3x plus 9. When you have a perfect cube in the problem, there is going to be a factor that cancels with that. And if you notice, the denominator had that x squared minus 3x plus 9. It's right here in the numerator that we get from factoring the perfect cube. So if we cancel those two out, they're gone, totally gone, those two factors. Brooke, what other factors can we cancel out? Or reduce, maybe I'll say. The 2 and the 4, these are numerical values still being multiplied. There's no addition sign next to the 2, it's 2 times. So they can reduce as well. So numbers reduce, factors cancel. And when we reduce the 2 and the 4, the 2 goes away and the 4 reduces to 2. So in the numerator, we have an x plus 3, and then in the denominator, there's a 2 and an x. Questions on 5? All right, so number 11 was the next one that I noticed that a lot of students weren't sure what to do as I was checking this last night. Factor first. So you must factor before you do any canceling. That is the biggest thing that you have to remember. You can't cancel terms. You have to cancel factors. So there are many different methods that we have learned to factor. We have GCF. We have the difference of two squares. We have the AC method, the AC grouping method, and then we have perfect cubes. It's a lot of types of factoring. It's kind of a requirement that you remember those types of factoring. So in math, you use it and it never goes away. You continue to use it. It spirals back, especially factoring. So looking at the numerator here, Ava, x squared minus 4. What do you think you would do with that to factor it? Yeah. So that's a difference of two squares. So a minus 2 and a plus 2. Let's go to the next numerator, Ava. What could we factor with that? Yeah. And you're left with? Right. That is greatest common factor. So difference of two squares, greatest common factor. Two different methods of factoring. Now we have to look at the denominators. The one on the left, 3x squared minus 10x plus 8. Ava, is there a GCF there?
No.
No. That should be the first question you ask. Is there a GCF? If you say no, then you still have to factor it. And we have factored problems with the coefficient in front. That's the AC grouping method. So we need to take A times C, which is 24. And then we need two factors of 24 that combine to be negative 10. Jordan, do you know what two numbers that would multiply to be 24 but combine to be negative 10? Yeah, negative 6 and a negative 4. So when you factor this, it's not just a one-step factoring because the coefficient is 3. This is the grouping factoring. So we have 3x squared minus 6x minus 4x and then plus 8. That's AC grouping because there's a coefficient in front of x squared. You continue to group by pairing the first two together and taking out what they have in common. So that's a 3 and an x. The second pair have a negative 4 in common. And then remember, the special thing about AC grouping is that when you pull out the greatest common factor of the pairs, the quantity in parentheses is the same. So this ends up factoring as 3x minus 4 and x minus 2. But it's not a one-step factoring problem because the coefficient in front totally changes the process of factoring. So 3x squared minus 10x plus 8 using AC grouping becomes 3x minus 4, x minus 2. So group the number in front together, and then you group the parentheses together. So that was the third way to factor this problem. Let's look at that last denominator. Julia, 2x cubed plus 4x squared plus 8x. Is there a greatest common factor? Yeah, let's pull out a 2x. And then Julia, what do you have when you pull out that 2x? Check to see if you can factor that. So I need to check factoring. A times C is 4. Julia, is there any way that we can take the multiples or the factors of 4 and make it a 2? No. So that one doesn't factor. So it's just going to stay as x squared plus 2x plus 4. So I cannot break that down besides taking a GCF out. So this problem required 3 types of factoring. Difference of two squares, GCF, and the AC grouping. After it's factored, then you go crazy canceling. So, Grace, what cancels?
X minus 2, 3x minus 4.
Oh, I missed my 3 up here. Thank you. Okay.
And then 2x.
Yeah, so x minus 2. 3x minus 4, and she said the whole 2 times x cancels with the 2 times x underneath. So a lot of terms cancel out. And then if you look to see in the numerator, what do you have left? Go across the whole top. Whatever's left gets multiplied together just as parentheses, while there's just an x plus 2 on the top. And on the bottom, the only thing that's left is that last quantity, which is x squared plus 2x plus 4. Remember, if it's addition, it cannot cancel. If it's subtraction, it cannot cancel. The only time you can cancel is when you have multiplication or a product. Questions with number 11. All right, we're gonna look at one more, and that one is number 12. Number 12 has no addition or subtraction signs, so you don't have to factor number 12. Factoring only occurs when you have multiple terms, a binomial or a trinomial. Well, this one, we're just dividing. So, Gabby Soul, when you divide, what are you actually doing?
With the second fraction.
Yeah, so the second fraction, whatever follows the division sign, that flips. Because division is really multiplying by the reciprocal of whatever follows the division sign. So the second fraction becomes multiplication. And now you want to try and see if you can simplify this or reduce it. So look at the numbers first. Try and reduce those numbers. Or look at the variables first. Try and reduce the variables. So Gabby, so what did you see that you said you could reduce or cancel out?
The second fraction, it would become 9/4. And the top would be
So you said 9/4 because we could divide them by 6.
the 9 would have an x and a y squared.
So she's then canceling this x cubed with that x squared. So the x squared cancels. This becomes a 1. She canceled the y cubed with the y, and she said it becomes a y squared. Again, this is one way that you can work through the problem. So she just looked at that second fraction and pretty much focused on the second fraction and canceled it. Gabby, is there anything you can cancel or reduce from the first fraction? Yeah, what can we do with those variables? And then the y in the denominator becomes a 1. So I'm going to rewrite what I have because I kind of wrote on top. So we have a 16 and an x, an 81 and the y. The next one has a 9, an x, y squared, and then a 4. So you could do two things here. You could multiply across because it's multiplication. Multiplication means top times top. And then you could multiply the bottom. Or you could continue to reduce, which is what I would suggest. When you reduce, not only do you reduce vertically, but you can cross reduce or cross simplify. So this 16 and the 4. 16 is in the numerator. Even though the 4 isn't in the same denominator, eventually these two fractions are going to become 1. So I can take 16 and 4 and reduce them. 16 reduces to 4 and the 4 goes away. So the 16 and the 4 can reduce. Looking at the other diagonal, the 9 is in the numerator, the 81 is in the denominator. They can reduce. 9 goes into 81 2 times. looking at the variables, doing that same process, there's a y in the denominator on the left and a y squared in the numerator on the right. So we can take the y on the left and make the one on the right just a y. So not only can you reduce vertically, but when you're multiplying, eventually everything on the top is going to be multiplied. Everything on the bottom is going to be multiplied. So you can also cross cancel or cross simplify. So looking to see now what you have left in the numerator, there is a 4, there's an x and another x. So Grace, what would you have in the numerator?
4x squared.
Oops. And then in the denominator, we have,
9.
oops, why did I write a 2? Yeah,
No, wait, no, just 9.
just 9. There we go. Apparently I can't write today either. So reduce within the fractions and then reduce diagonally. Cross cancel those terms, both the numbers and the variables. So we end up with 4x squared y over 9. Again, that's like one way that you could do it. There's many ways. It kind of depends on what you see first. But that would be a good starting point. Reduce within its own fraction and then cancel diagonally. Questions? So today we are going to talk about the least common multiple. And we have just a few problems that we're going to look at. The whole goal is for us to focus on that least common multiple today, so that tomorrow we can apply it to the actual fraction itself. But we're going to talk about the process of finding the least common multiple today. When your fractions, instead of a division sign, turn into an addition sign, or maybe they turn into a subtraction sign. So how can I add these fractions together, or how can we subtract the fractions? So if you go to that extra little note sheet that did not make the packet, there's a little warm up here. So our goal today is to find least common multiples for numbers, terms, and variable expressions. In the warm up, list 10 different multiples of 12, and then list 10 different multiples of 8. Remember, a multiple is counting by that number. So multiples of 3 would be 3, 6, 9, 12, 15, 18. So see if you can get 10 multiples of 12, 10 multiples of 8, and then try and answer questions 3 and 4 as well. So this will kind of get you into the thought process of this least common multiple that we're going to talk about. How well do you know the factors of 12, the factors of 8, or the multiples, I should say, the multiples of 12, the multiples of 8? I'm not really sure they fixed it.
What's it like? What's wrong with that?
Well, I opened the door this morning and it was 78 point.
Oh, boy.
It was
Oh.
really hot in here. It was like a wall of heat.
Oh, my God.
So I asked them to look at it.
Yeah, it feels normally like more air would be blowing, like, I don't know, a little bit. I'm fine right now, but like.
It was really warm when I opened the door. So it's still 75.
Oh my God.
Yeah. I don't think they have the air conditioner on in the building yet, but it probably should be on since it's going to be 80 degrees today and 78 tomorrow and still warm on Friday. But you know, what do I know? Just teaching. Just stick with math, Mrs. King. Like once the sun comes around, like the front of the building gets so hot because like those windows just absorb that sun and ugh. Because I mean, we have really high quality windows over there too. They reflect the sun, they don't absorb it. All right, so everybody at home, your home is probably nice and cool. The classroom is quite toasty this morning. Multiples of 12. How far was I supposed to go? 10. I need one more. I think I got 12 there, or 10 there. And then multiples of 8. Again, list the multiples of 8. This would be a good exercise for my 10-year-old. Just have her list the first 10 multiples of what? The first 20 numbers? Sounds good. She never has homework. I bought her a separate math book so that every day she's doing math. I got her the 5th grade math book because 4th grade just seems too easy. So we're just doing 5th grade math because she doesn't have homework. Don't you wish I was your mom? Lucky kids I have. All right, so I lost concentration here. 72, 80. There we go. All right. Look at each of your responses. Brooke, circle the numbers that are the same in both. Which ones are the same, Brooke? Oh, wow, you are an overachiever.
No, I went to 12.
Oh, I gotcha.
24. 28.
And then out of those numbers, Brooke, which is the smallest? 24. So a least common multiple is also referred to as a least common denominator. You're going to see it as LCM or LCD. It depends on if you have a fraction, it's a least common denominator. If it's not a fraction, it's a least common multiple, but they're the same thing. So if it's in fraction, least common denominator. If it's just two expressions, least common multiple. It is defined as being the smallest of the common or similar multiples of two numbers, terms, or expressions. So the two numbers above, the least common multiple would be 24. So the least common multiple of 12 and 8 are 24. It's the first number that both of them divide into. So it's different than a greatest common factor. It's kind of opposite. So the least common multiple of 12 and 8 is the first number that they both divide into, and that number is 24. We are going to work on finding least common multiples today of expressions, not just numbers. And of course, we've got a little process to help you do that. 2 steps that we take to find the least common multiple or the least common denominator of a pair of polynomials. So a polynomial is an expression containing x. The first step, look at that wonderful F word right here, factor. That's the first step. The first step of simplifying is factoring. The first step of multiplying is factoring. The first step of dividing is factoring. So it makes sense that the first step of finding a least common denominator or a least common multiple is to factor. Step 2, compare the individual factors in each polynomial. If common factors are missing, insert them into the least common denominator of the two polynomials. All right, so what does that mean? If you look at the next page, there are 4 examples that we're going to work on finding the least common multiple. The first step is to factor. So we have 2 expressions. We have started off easy here. One is 3x. The other one is 3x minus 6. The first step is to factor those expressions. Well, 3x doesn't have a plus sign. It just stays as 3x. Riley, how could we factor 3x minus 6? Yeah. So it has a GCF of 3. So we would pull out the 3. So the one on the left is not factorable. It's just 3 times x. But the one on the right, we can take out a 3. So it's now factored. All right, step 2. Here's where we want to find the least common multiple. Start by writing the factors of the one on the left. All right, well, the one on the left is just 3x. So I'm going to write the one on the left. So you're always going to start with the left fraction. Write that entire denominator, or write the entire piece, the entire polynomial. Compare with the factors on the right. Insert any factors that may be missing. Well, if I look at the left has a 3 and the right has a 3. The left has an x, the right doesn't, but that's okay. But the right has an x minus 2. So that means that's the missing factor that needs to go along with my least common multiple. So a multiple means multiplication. The least common multiple is really a list of all of the factors of the denominator. If one is already there, I don't write it again. So the 3 was already there. I'm not going to write it a second time. But the one on the left has an x, so it needs an x. The one on the right has an x minus 2. So my least common multiple has to have each one of the pieces that are different between both of those fractions. So least common multiple is 3x and then x minus 2. So the x minus 2 is different than the x that's by itself. It's a different factor or a different piece. So let's look at the next one, see if we can try this again. Step 1, these polynomials are not factored. We must factor first. So looking at the first one, x squared plus x minus 2. The second one is x minus 1 quantity squared. So that one is factored. I'll just write that again. Ella, how would you factor x squared plus x minus 2? All right, so there are my two factors. Put a little line down the middle. Start by writing the factors on the left. So to get my least common multiple, the factors on the left are x minus 1 and x plus 2. Compare with the factors on the right. Insert any missing or any factors that may be missing. The one on the left has an x minus 1 and the x plus 2. The one on the right has x minus 1 squared. Ella, what does it mean if you have a quantity squared? There'd be 2 of them. That's something squared, means there are 2 of them. So you have one x minus 1. That's the same. But the one on the right has a second x minus 1. It's a different factor. It's a second one of them. So your least common multiple needs to have that second x minus 1. So it contains the one on the right or the one on the left, all of the one on the left. Anything that's the same from left to right is already there. But there is an extra factor of x minus 1. Why wouldn't you? It is factored. So you don't want to FOIL it. I don't want to multiply them together. It is already factored. So once it's in parentheses, it's factored form. This one? That it's x minus 1, x minus 1, because it's a quantity squared. So you could write your least common multiple in 2 ways. You could leave it as just the 3 parentheses, or you could say, well, these 2 parentheses are the same, so I'm just going to write the x minus 1 squared, and then the x plus 2. Either way, sometimes it's easier to think of it not being squared, so you understand that there are 2 factors of x minus 1 there, but they're the same, so it's squared.
Why is there to X minus one, because on your website, why, like if you cancel that out, isn't it gone?
So you canceled one of them out, but this was squared.
So there's one more.
So there's one left. That one left needs to go in your least common multiple because of that one piece that is left. It's still sitting there.
But there's two X minus
Right. Because they have one in common, and then the one that's left needs to become part of the least common multiple. Just like this x plus 2. So this x plus 2 needs to be part of the least common multiple. Any different factor needs to be part of the least common multiple. So there are two of them. The first one they have in common, we already wrote that down. They have that in common. And then I still have that second one that I didn't cancel because it wasn't originally written. So anything that isn't there needs to be listed. That's missing or wasn't originally there, anything that's left on the right side, anything that's remaining on the right side needs to be written in the least common multiple. All right, so looking at example 3, find the least common multiple of 9x squared minus 16 and 3x squared minus 2x minus 8. Factor first. So 9x squared minus 16, that's our difference of perfect squares. 3x minus 4, 3x plus 4. The second one is a trinomial. Lacey, what two numbers multiply to be negative 24 but combine to be negative 2? All right, here's my factors of 24. Yeah, 6 and 4. So a negative 6 and a positive 4 because it's a negative 2. So we have to factor this. So we have 3x squared. I'm going to write the 6 next and then the 4 so that my numbers pair up a little better. Negative 6x plus 4 makes negative 2. Jordan, what would you pull out of the first pair? And the second pair? Yeah. So Jordan, that would factor as? So 3x plus 4 and x minus 2. So to find the least common multiple, start by writing the factors to the one on the left. So the one on the left is 3x minus 4 and 3x plus 4. So those are the factors of the one on the left. Compare with the factors on the right. Insert any factors that may be missing. So Gabby Soul, what's missing on the right? Yeah, the x minus 2. So the 3x minus 4 is there. It's not missing, but there's not an x minus 2. So just like the one above, the x minus 1 was there, but not that leftover factor. So anything that's left needs to go in the least common multiple. Anything that remains needs to become the least common multiple. So everything on the left side, and then anything that still remains after you cross off the common piece becomes the least common multiple. Questions?
So for the left side, you know that it's on the left side just because it comes first in the problem.
Yes, and it's always going to be there. So any factor that's there is always going to be part of your least common denominator. So just start with the left, write everything down, and then compare with the right side. All right, let's look at this last one. So find the least common multiple of 15x squared y squared z cubed and 25xy to the fourth. Do they need to be factored? No, because there's no addition sign. You only factor when there's addition or subtraction and it's an expression that's a binomial or a trinomial. So that means we have to look at the numbers first. We need the first multiple or the first number that both 15 and 25 will divide into. So think of your multiples of 15 and your multiples of 25. So 15, 30, 45, 60, 75, 90, 25, 50, 75, 100. Is there a number, the first number that they would have in common? Ella? 75. 75 is the first number that they divide into. So the least common multiple is going to be 75. And then write everything else from the left side. Well, the left side has an x squared, a y squared, and a z cubed. On the right, we already have an x, and I have 2 y's, but the right has 4. So how many more y's do you need? 2 more. So I would have 75 x squared y to the fourth and z cubed. So your homework is finding least common multiples. It's a worksheet. The second part of the worksheet, they're in fraction form, but you're only finding the least common denominator. You're not doing anything with it. So yes, you have fractions just to get you used to seeing it in fraction form. But again, you're only finding the least common denominator. Have a fantastic day.